Okay, so the fifth problem is going to be finding a projection matrix. So what we want to do, this is the main formula that you're going to be dealing with. And so we're going to find a projection matrix for the plane that is spanned by V1 and V2. So V1 and V2, their linear combinations will create a plane, okay? And so we're going to look for the projection matrix of that plane, and then we're going to project this vector right here onto that plane, okay? So we're going to have to start out with A transpose A as our first step. So okay, so 1, 1, 1 acting upon 1, 1, 1, well, that's 1 plus 1 plus 1, just 3. That's a 1. That would also be 1, that would be a 1. Okay, so the first step is to just find A transpose A. Great. Now we need to find the inverse. All right. So we take A transpose A and augment it with the identity matrix. Right? So the first thing I'm going to have to do is multiply by negative 1/3 and add. Okay, so the top row doesn't get affected. The entire point of this is to turn that into a 0. All right, now if I take 1, I multiply it by negative 1/3 and add it to 1, that's going to give me a positive 2/3. And that would still be negative 1/3, and that would still be a 1. Okay? And then I'm going to multiply by 3 over 2. Okay. So it's 3, 1, 0, 1, augment. 1, 0, that would be negative 1 over 2, and that would be 3 divided by 2. Okay, and now I'm going to take this row and I'm going to multiply by negative 1, and I'm going to add up 1s. Okay, so that would be 3, 0, 0, 1, augment. Augment is not being affected. That would be a negative 3 over 2. Okay? And now negative 1 times negative 1/2 would turn into positive 1/2. 1/2 plus 1 would also be a positive 3 over 2. And now we divide by 3. Right? 1, 0, 0, 1. Now augmented with negative 1 divided by 2. 3 divided by 2, 1 divided by 2, negative 1 divided by 2. All right, and I'm just doing this problem off the top of my head, so why don't we go ahead and let's go and do the step that you all should take, and let's verify that we really did find A transpose A's inverse, okay? So, what would happen if I multiplied 1/2, negative 1/2, negative 1/2, and 3/2 by 3, 1, 1, 1. Okay. I'm really going to run out of room. All right, so 3 over 2 minus 1 over 2. Okay? 1 over 2 and negative 1 over 2 acting upon like right there. That'd be 0. Okay? And then negative 1 over, wait, no, right here. negative 1 over 2 acting upon 3 with the 3 halves, those cancel each other out, and that becomes a 0. And then negative 1 half and 3 halves acting upon 1 and 1, well, 3 halves minus 1 half is 1. Okay, so we do have the right inverse, so it's good to just at that step do that. All right. So now what we're going to look at is A transpose, A inverse, A transpose. Okay? So that's going to be 1, 1, 1, 1, 0, 0. Now acting upon 1 half, negative 1 half, negative 1 half, and 3 halves. Okay? And that's going to act upon 1, 1, 1, 1, 0, 0. Right. So that's going to equal 1, 1, 1, 1, 0, 0. All right, now 1 half, negative 1 half, that's a 0. 1 half, 1 half. Negative 1 half and 3 halves acting upon this one, what's that going to produce? That's going to produce 1. And then that's going to be negative 1 half, negative 1 half. Okay, so 1, 1 acting upon 0, 1, that's just going to pick up a 1 half, negative 1 half, that's a 0, that's a 0. 1, 0, that would be a 0. 1, 0 acting upon that would be 1 half, 1 half. And that would turn out to be a 0, and that would be 1 half, and 1 half. Okay. So, that's our projection matrix. Now, remember that whenever you're checking if you have the correct projection matrix, have the projection matrix act upon the vectors that already lie within the plane. Okay, so 1, 1, 1. If this guy acted upon 1, 1, 1, what would it do? It would spit out 1, 1, 1. If it acted upon 1, 0, 0, what would it do? It spit out 1, 0, 0. But if it acted upon 2, 1, 1, the addition of the two vectors, still got 2, 1, 1. All right? But we're not done with this problem yet, okay? Because the problem said that we need to have this matrix project another vector onto that plane. This is part of the problem a lot of people have a tendency to forget. And so, let's have that matrix act upon 2, 1, and 3. Okay, 1, 0, 0, that's pretty straightforward. It's just a 2. All right, now 1 half, 0, 1 half, 1 half acting upon this, it's going to turn that into a 1 half, and that into 3 halves. Okay, so 1 half plus 3 halves, that's 4 halves, which is 2. That's also a 2. Okay. So that is the projection matrix acting upon the vector that's sticking out of the plane. And what it ended up being? It ended up being parallel to 1, 1, 1.